me know. You can come back during the free period or study hall or before or after school. All right, once you get to right here, you gotta get both terms with an x on the same side. So let's say you subtract that. And now you gotta factor out the x. And then you divide with that. Okay? Yep.
There's a line in so four.
He is. I got it. Do whatever you want, do you?
Solve my completing square. I'll put it in like a
Right there. Oh, man. Well, maybe next time. All right, that's homework wise. Let's take a look at that. First, see what questions you have. I definitely want to look at 61. I'll show you that. And then anything else, there's 46. It should be 2 or -8. Check your answer for 46. And 48 should be 0 and 4/7. I believe that's equidistant to the y-axis. So you should have 0 and 4/7 for that. Anything before 61? We need to take a look at. Take that as a no. All right, take a look at 61. It says, show that this is true. Show that h squared equals a squared plus b squared plus c squared. When you have something like that, one thing you can't do is you cannot use that in your process. Okay, you cannot use that in your steps. That has to be the last step. So you can't use it and go backwards. This one here, a lot of times you'll come up with situations, you can add a line into a figure. And what I mean by that is I'm going to draw this in, is that diagonal. And I'm going to call that D. Now that's a right rectangular prism. Okay. What can you tell me about the triangle formed by A, B, and D? What type of triangle does that have to be? Got to be a right triangle. Well, if it's a right triangle, Pythagorean theorem works, right? Well, what would the Pythagorean theorem tell me for that right triangle? How would you use it? Katie?
A squared plus b squared equals d squared.
So a squared plus b squared equals d squared. All right, I agree. Now look at this. With this H, D, and C, what type of triangle does that have to be? Right triangle. So Justin, using Pythagorean theorem, what would it be?
H squared, C squared plus D squared equals H squared.
Okay, C squared plus D squared equals H squared. All right, we are essentially done. Let's go do one more step. We're done. Anybody see it? Okay.
We've got to substitute out the d squared for the a squared plus b squared.
Okay, D squared right here is equal to A squared plus B squared. So I can take that out and I can put in A squared plus B squared. Now the only thing it's not in the same order, I can just reverse the order and say A squared plus B squared plus C squared equals H squared. There you go. So you just proved that. You just verified that fact is true. If those three squared have to add up to H squared. So the one thing you can't do, as I said earlier, cannot use this within the problem. Okay. You just got to show that. All right, we good on everything else, though? Sure? All right. All right, we're going to keep going in section 2.2 for this. All right, it says, without using the graphing capabilities of your calculator, sketch a graph of the following function. All right, y equals x cubed plus 4x squared. So we just want to do a sketch of that one. So you can't just type it in and hit graph. How in the world would we do that? Okay, how are we going to sketch that? Holly? That's what I'm here for, right? All right, any ideas? Marissa?
There's like a certain shape that it has to be.
All right, it has to be a certain shape. Possibly, yeah. Is it a straight, first of all, is it a straight line? Is it a parabola?
Isn't it like the one with like the flippy thing?
The flippy thing? Could be. Could have the flippy thing on there. All right, here's what I want to tell you to do. I want everybody to pick 2 points, and if you're sitting with somebody, don't pick the same 2 points. Plug them into the equation, plug 2 x values, and get a y value. And you get two ordered pairs. And if you sit with somebody, make sure you do 2 different ones. All right, see what you come up with. Figure out some points. You can use your calculator. You can plug them in.
I said 1 and 3.
I'll take 2, 2, and 4, 5.
2, 2, and 4, 5.
Can you not do that?
No, you plug in 2 and see what you get for an answer. And you plug in 4 and see what you get for an answer.
Oh, so solving for that.
Yeah, that's how you would plug in. You plug in an x value, see what you get for y. So if you're saying 2, 2, you're just checking to see if that's true. We wouldn't do that. We want to see what y value you get back. So just pick any 2, plug them in, see what you get back. Hayden, what do you got? Give me a couple points. What do you got? Crozier. Hayden.
1, 2.
So you plugged in the number 1 and you got back 2.
Oh, no, actually, I didn't get that.
Okay. Because when I plug in 1, I don't get back 2. So do you understand the process?
Yeah, you plug it in and it's supposed to be.
All right, just figure out what it equals y. Dakota, what do you got?
I picked 2 and I got 24.
All right, you got 2 and 24. That's not even on my graph right now. I'll come back to that one. All right. What else we got? Holly, what do you got?
I did 4.
Oh
and
boy.
then I got 428.
428? All right, I see exactly what this looks like now. Did you do anything else?
It's 128.
Oh, 128. Okay, oh good. Not that bad.
I did 2.
2 and 24? All right. What'd you do?
I did 1 and I got 5.
1 and 5? All right, I can at least plot that one. 1, 2, 3, 4, 5. All right, what else we got? Oh, there we go.
Yeah, 3 and 63.
3, oh great. 3 and 63. So 2 and 24, that's somewhere up in here. And 3 and 63 is probably up there. And 4 and 128 is a little bit higher. All right, anybody got anything that'll show up?
0, 0.
Oh, 0, 0. That's a very nice point. Lovely. What else we got? Anything else will show up? So we clearly know what this graph looks like, right? All right, go ahead, do your calculators. Go to y equals, plot those, type in x cubed plus 4x squared and hit graph. So x cubed plus 4x squared, when I hit graph, I get something that looks like this. Hey, why is it not coming in? Oh. Is that what our 2 points look like? Or 3 points? No, we had no idea what this looks like. Now it also hits at negative 4, 0. 1, 2, 3, 4. I believe what happens when we plug in negative 1. Negative 1 should give us back 3, I believe. But here's the general shape. Why didn't we get it to look like this? Because we didn't pick the right points. You just picked 1, 2, 3, and 4. Those are still points on the graph, but we didn't pick points that showed the whole picture. So in order to see the graph, basically you can always sketch a graph by plotting points. The more points plotted, the more accurate the graph. So you want to get a picture of what it's going to look like. If you don't pick the right points, you're not going to get an accurate picture. Okay. This is a geometric picture of all the solutions. Those are all solutions to the equation. When I plug in 2, I get back 24. 4, 128. 1, 5, 0, 0. Those are all solutions. So we're just graphing every solution and we want to see what it looks like. Well, I don't want to just randomly plug in points. Okay, we want to come up with a kind of a basis. One of the things that help are x and y intercepts. If we can figure out what those are, it'll help us plot key points and maybe figure out what other points to test. Well, x and y intercepts. You got that figure there on your notes. This right here is an x-intercept, negative 2, 0. This right here is a x-intercept. It is 3, 0. This point here is a y-intercept. It is 0, 9. Now, if you're given an equation, do you remember how to find the x and y intercepts? If you look over there to the right, it says to find the x-intercept. Do you remember what you do? Set y equal to 0. Because the y value has to be 0. So to find the x-intercept, set y equals 0 and solve for x. What do we do to find the y-intercepts? You set x equal to 0 and solve for y. So algebraically, we can figure out where these values are. And then if I know these values, it gives me a little bit better idea what the picture looks like. All right, so that's the idea. All right, so down there on the bottom, find the x and y intercepts of the graphs of the following equations. So we're going to do 3 of them. We got the first one there. All right, do you know what that graph looks like? First of all, 5x minus 2y equals negative 30. Adam, you know what it looks like?
It'll be linear.
It's linear. And define linear for everybody
It'll be a
else.
straight line.
There we go. Straight line. It'll be a straight line. So, all right, we want to find the x and y intercepts. So for the x-intercept, let y equal 0. And so that's going to be 5x minus 2 times 0 equals negative 30. Well, 2 times 0 just wipes that whole thing out. I get 5x equals negative 30. Divide by 5. Divide by 5. And then I get x equals negative 6. Now don't forget, it's going to be an ordered pair. Negative 6 comma 0. So I know the x-intercept. All right, for the y-intercept, I'm just going to go beside here. For the y-intercept, let x equal 0. And that's going to be 5 times 0 minus 2y, bless you, equals negative 30. Negative 2y equals negative 30. Y equals 15. Is at the point 0, 15. Do we have enough to know accurately what this graph's going to look like? It's linear. It's a straight line. How many points do you need for a straight line? 2. Do I got 2 points? Yeah, I got 2 points. So negative 6, 0 is just going to be somewhere over here. 0, 15 will be up here. And I can connect those and get a straight line. So that gives me enough. So 0, 15 and negative 6, 0. All right, second one. Y equals x squared plus 4x plus 3. Aiden, you know what this graph looks like? Okay, good. Aiden knows what it looks like. What does it look like? Never mind? No, okay. We had a yeah. So no?
No.
Anna, what's it look like? It is a trinomial. You know what the picture looks like?
Oh, It's supposed to look like a U.
A U. What's the fancy name for that?
Parabola?
Parabola. Does it have to be a parabola? Yes. Yes, it has to be a parabola. Okay, it's not going to be a straight line. It's not going to be a straight line. It has to because you got an x squared in. All right, how about for the x-intercept? X-intercept. Let y equals 0. So I get 0 equals x squared plus 4x plus 3. All right, now it's not exactly the same as last one. Okay? But I can still solve it. How do we solve it? Factor. Okay, so we got a quadratically factored. So it factors into x plus 3 times x plus 1, because 3 times 1 is 3, and 3 plus 1 is 4 in the middle. And so I get x equals -3, x equals -1. So I'm going to get 2 points, -3, 0, -1, 0. All right, now we want the y-intercept. Y-intercept. Let x equal 0. So I'm going to let every x equal 0. I get 0 squared plus 4 times 0 plus 3. So what am I left with? 3, right? So y equals 3. All right, we may or may not have enough information to get an accurate graph. We're not going to have everything perfect, but I think we can have a very good sketch of it. So just take a look at what I have. I got -1 and -3. And then I also have a y-intercept of +3. It's got to be a parabola or U-shape. It's got to hit all 3 points. And you should know this already. Will it open up or open down? Open up. Because you got a positive x squared, and to hit these points, it has to open up. So it's going to come through these points. Looks something like this. I don't know how far down it goes. I don't know that, but at least I know it hits those 3 points. Okay, and that's the only way that can happen. All right, so that's a parabola. All right, the third one there on the bottom. X squared plus y squared equals 9. Most people usually don't know what this looks like. Okay. Does anybody think they know what it looks like? Coders is trying to go back to the memory bank here. All right, let's just at least find the x and y intercepts. X-intercept, let y equal 0. Well, it basically takes out that y. You get x squared equals 9. Now, when you take the square root, don't forget it's plus or minus square root of 9. So x equals plus or minus 3. So that's actually how many x-intercepts? 2 of them. So I get 3, 0. That's a 3 and a 0. And I get -3, 0. All right, y-intercept. Let x equals 0. And then that just gives me y squared equals 9. What do I get for that?
Plus or minus 3.
Plus or minus 3. Same thing. Square root of y squared plus or minus square root of 9. Y equals plus or minus 3. That's 0, 3, and 0, -3. So I got 4 points. Those are 4 points that have to be on this graph. Those are 4 solutions. 1, 2, 3, 4. -3, 0, 0, 3, 3, 0. Now most graphs are all going to be connected. They're not going to, you're not going to be able to pick your pencil up. Okay, join all 4 points. Okay. Circle. Yep. X squared plus y squared equals 9. It's going to be a circle. Okay, for that one. But it still has 2 x-intercepts. It still has 2 y-intercepts. Got to be able to connect them all. So you need to be able to find x and y intercepts for different scenarios. We had a linear where they can have one of each. We had a parabola where you could have 2x and 1y, and then here we have 2 and 2. So that's one key part of graphs. Okay, x and y intercepts. Another thing that is helpful with graphing is what's called symmetry. With symmetry, if you find one point, you can locate another one just by going across a line or across a point. So flip it over on the back. I believe that's where we're at. So you got if something is symmetric with respect to the y-axis, basically the y-axis is like a mirror. You got one point on one side, you got a mirror point on the opposite side. Algebraically, here's what's happening. If xy is a point on the original graph, negative xy is a point on the opposite side. Always going to be the case. If it is symmetric with respect to the x-axis, what's going to be true? If xy is on the graph, then x negative y is also on the graph. So here's xy, and then you should see that across that axis, that would be the point x negative y. The x values are the same. Doesn't matter whether if y is positive or negative, you get the same x. And then we got symmetry with respect to the origin. If that's the case, if xy is on the graph, then negative x negative y is on the graph. You can see that here, 3 7s on the graph, and then -3 -7s on the graph. Here's how this works. It's not a mirror image across a line. You go through the origin, you go through the point. And any point on one side, if you draw a line through the origin, you'll get the mirror point on the other side. Okay, so that's kind of how that works. A little bit different. Testing for symmetry, you got to be careful here. All right, we're going to use this for the first three. This is check x squared equals y cubed for symmetry. Okay, we're going to check it in the y-axis, the x-axis, and then, and then the origin. That picture is not the graph. That is just to give you a visual for y-axis symmetry, and it's not on your sheet. I know that. All right, here's how you check something for y-axis symmetry. Start with your original equation. X squared equals y cubed. We said for y-axis symmetry, if xy is on a point, is a point on the graph, then negative xy is on the graph. Basically, it doesn't, if you plug in x or negative x, you get the same answer. So take the x out, plug in negative x. Here's what you're going to do. You're going to simplify this, and if you get back the original equation, then it does have symmetry in the y-axis. Well, what's negative x squared equal? It's just what? It's just x squared. Do we get back the original?
Mm-hmm.
That means that, yes, it has y-axis symmetry. So once I found one point, I could find the mirror point on the other side. So this does have y-axis symmetry. Okay, let's just keep moving down the line. What about x-axis symmetry? If something has x-axis symmetry, if you negate the y, you still get the same answer. So here's how we test it algebraically. You take the y out and you plug in negative y. So x squared equals y cubed is the original. We get x cubed equals negative y to the third. Simplify that. Negative y to the third is what? Is it going to become positive or is it going to stay negative? It's got to stay negative, right? So this is x squared equals negative y to the third. Is that the original equation? No. So what does that mean? It means there is no x-axis symmetry. And now for the last case. Now, sometimes people think if it already has X and Y axis symmetry, it has symmetry about the origin. You just got to be careful. I already said this graph has symmetry about the origin. Does this have X or Y axis symmetry? It has neither. So just be careful. Don't assume it's yes or no. So for this one, we replace X with negative X and Y with negative Y. And so that becomes negative X quantity squared equals negative Y quantity cubed. That becomes positive. That will end up being negative. So that means what? It means no symmetry about the origin. Okay, no symmetry about the origin. Okay, is that the last one on the bottom?
Yeah.
Okay. And we're just going to attack this with symmetry about the origin. Is y equals 4x cubed minus 5x symmetric about the origin? So what we want to do is we replace x with negative x. Replace y with negative y. And so that becomes negative y equals 4 negative x cubed minus 5 times negative x. So that is negative y equals, all right, 4 times negative x to the third. What does that end up being? Negative. So negative 4x cubed minus 5 times negative x is plus 5x. All right, you need to look at it close. Is this symmetric about the origin? Yes, it will be. Does it look exactly like the original equation? Not yet. Question is can we make it the same? Yeah, what's the only thing we need to do?
Divide by -1.
Yeah, you can divide by -1. That doesn't change anything. Or that still keeps the value the same, and we get y equals 4x cubed minus 5x. So it will change all those signs back. So if everything is negative from the original, it will be symmetric. So this is yes, symmetric about the origin. All right. We're going to finish the rest tomorrow. We'll give you a few problems to do, though, just over symmetry and X and Y intercepts. We'll hit the rest of this section, like I said, tomorrow. Anything?
My homework last day wouldn't submit on Canada.
It wouldn't? All right, let me.